So hello, my name is Norbert Sabo, and I would like to talk about how to do spatial computable general equilibrium modeling in GAMS. First, I would like to talk shortly about the model structure. It's a standard computable general equilibrium model based on many simplifications and assumptions. So what we have here is basically the connection between the supply side and the demand side. Now we assume that we have different regions, region R and region Q, and what is produced in region R based on labor and capital inputs, which is going to be value added, that can be used or consumed in other regions as well through interregional transportation or trade captured by QR, where we also have to account for the transportation cost. Now, the production of region R can be used only for consumption purposes, which is captured by C. So we only assume that in our simple model we have households and we don't take into account investment sector, foreign sectors, government, etc. So it's a very simple model. And when you do a large-scale impact assessment, of course you have to take into account many other things as well. So the model itself is recursive dynamic, which means that we have different time periods, and within one time period the model will behave as a static model. The static time periods are then connected through investment, capital accumulation, and interregional migration, and that's how the model will behave as a dynamic model in the long run. Next, I would like to talk about the data. Okay, so we have a model folder, and within the model folder we have a couple of files. I'm going to talk about them later. So we have an Excel file here that you can see, and this Excel file contains all the data we are going to use for the SCGE model. The first worksheet contains a very simplified version of an interregional social accounting matrix, SAM. And in this SAM is basically what we have is the data for a country, or in this case for a country with many regions for a given year, let's say 2018 or 17, and it describes the transactions, the monetary flows between different agents within the economy. So in this case we have industries, aggregated sector, we have households, and then we have labor and capital accounts to account for labor and capital inputs and labor and capital income for households. So in this case the rows and the columns can be interpreted as expenditures and income or purchases. So for example, when we have a household account, a household in region 1 can purchase from its own home region or from region 2 and region 3 through interregional trade. Now the production that happens in region 1 can be distributed or sold in region 1, region 2 and region 3 as well. That's the other side of trade. Since we have a spatial computable general equilibrium model, what we also have to incorporate in the model structure is transportation cost, which is captured by the parameter of tau. This has to be estimated in an impact assessment model when we are working with real data. What you can see here, including the SAM as well, the numbers are completely fictional, so they only serve educational purposes, and when you have the real data, then you can do calibration and simulation based on the real world example. In this example, what you can see is that the tau itself is kind of large in some cases and it's not symmetric. Also in the real world it doesn't have to be symmetric, but it doesn't have to be so far away from each other. I mean the numbers in different relations. Okay, so this is the database we are going to use in the model, and based on those numbers we are going to set the initial values of parameters and variables, and we are going to calibrate those parameters that are responsible for the behavior of the model. And this is going to be our next step in this video. So now I'm going to switch to GAMS, and we are trying to work with the GAMS file. So this is the GAMS window you are going to see when you start the program. The first thing you might need to do is to create project file. So you can scroll down to project, new project file, and you can look for the model folder you are using, where you have the data, where you have all the files you are going to work with, and you can create a model project file. I already have one, so I don't going to create it, but if you type in the name and you create it, you will have a project file. Now the project file will be important when we are going to write the results, or where we are working with the files in the folder, because this project file will tell GAMS that this is the folder we are working right now, and that's how GAMS will know that when it has to write results or it has to do anything with files within the folder, it doesn't going to use the default folder, which can be located somewhere in documents. Okay, so what we have seen here, we have the project file in the folder, the data file, and then we have a calibration and the simulation file. So let's start with the calibration file. I'm going to open it in GAMS. So calibration. Now this is the calibration file for the model. In this case, the first step what we have to do is to define the sets, the dimensions of the model, like the number of regions, the different agents in the model, the number of time periods, etc. And then we define parameters, initial values of the main variables, like L0 stands for labor demand, etc. We have the prices, or at least the initial value of prices. Then we have variables, or parameters for capturing the solutions in different time periods. We have indices for the change of the main variables, and we have some parameters for writing the results back into Excel. And then we have some share and shift parameters of CES functions and etc., which will describe the behavior of the model. So these parameters need to be calibrated in this file. It's a typical thing in SCGE modeling, and in the standard computer general equilibrium modeling also, that we set elasticities in advance. These elasticities usually are based on the literature, the result of the literature, or it can be estimated by the authors themselves. In this case, we just use some fictional data to illustrate what you can do in a real-world example. Another interesting thing of SCGE modeling is that we usually don't really have data on prices, or not in the detail what we are going to need, so like regional industrial data of prices. So that's why usually SCGE models assume that the initial value of prices are unity. So we assume that all the transactions, all the flows what we have seen in the social accounting matrix are going to be so-called real quantities in the model. This means that we are not going to calculate the actual price level in the regional economy, but we are going to look for the relative price change of the economy. So that means that the price what we can see in the SCGE model is actually just relative price compared to the numeraire. Next, it's an important part of the model. So this is where we are going to read the data, as you can see the path here, from the Excel file. So you have to make sure that this path is consistent with your model folder, and then you have the Excel file in the model folder. If you have the file there and reading is successful, based on that database, the code will set the initial values and calibrate the parameters of the model for the simulations. At the end of the code, what you can see is basically the model equations. Here we check whether the calibration is good or not, because when we do the calibration, what we do is that we fit the equations of the model for the available data. So when we have, for example, a labor demand function in a region, that labor demand has to be in line with the labor input captured by the social accounting matrix. If something goes wrong with the calibration, this is the part when we are going to see what we did wrong